Hello all, welcome to the new video of Signals and Systems. In this video, we'll study about time response of first order control system. In the last lecture, we were studying about the importance of time response, and we saw that time response can be further divided into transient response and steady state response. So before going in detail about the transient response, let's see what is the time response of first order control system. It means we'll be able to see what is the transient response and steady state response of first order control system. So before we begin, one must know what is the order of control system. So in any control system, it is defined by the transfer function h of s, which is equal to output c of s upon input r of s. So let's say the transfer function of any transfer function is s square plus 2s plus 1. So they'll ask you what is the order of this control system. So you should know that. So order of control system is defined as the highest power of s in the denominator of control system transfer function. In this case, the highest power of s in the denominator of transfer function of control system is 2. That is, highest power of s is 2 in the denominator. Hence the order of this control system is 2. Okay. In this case, we are studying about first order control system. So let's write the transfer function of first order control system. This c of s, this is output upon input r of s. So since it is first order, this is s into any constant tau plus 1. Okay. So this is the first order control system, and we can draw the block diagram for this. So this is the negative feedback control system. The transfer function can be found out by this in this way, 1 plus 1 over s tau. So this will come here and it will get cancelled, and eventually it will be s tau plus 1. Okay, this is cs upon r of s. So this is the block diagram of first order control system. Now let's see what is the time response of this first order control system. To do that, we need to have input. Let's say the input is unit step function. Okay, so the output can be represented as c of s is equal to r of s into h of s. So r of s into h of s is given 1 over s tau plus 1. So since the input r of s is u of t, okay, it means this is unit step function. Now since we are dealing with the Laplacian domain, we need to represent this u of t in terms of Laplace. Okay, Laplace transform. So we need to do Laplace transform for this. In that case, the unit step function will be 1 over s. Okay, so r of s is 1 over s in this case. So now what we need to do, we need to find out what is c of s and then convert it into time domain. Okay, so let's do that. So let's simplify this equation. So c of s is equal to r of s into h of s. R of s is the input, which is unit step function, and h of s is the transfer function of control system, which is equal to 1 by s into 1 upon s tau plus 1. So we need to simplify this. It can be written as 1 upon s upon minus tau upon s tau plus 1. Okay, so if you simplify this, we will go back to this, and then this can also be represented as 1 upon s plus 1 over tau. Okay, so this is c of s. Let's call it as 1. Now we need to apply inverse Laplace transform to get back to time domain. On 1, then we get c of t. This is equal to u of t, inverse Laplace transform of 1 by s is u of t, minus inverse of 1 upon s plus a is e raised to minus at. In this case, it is e raised to minus t by tau into u of t. So c of t can be written as 1 minus e raised to minus t by tau into u of t. Okay, so this is the time response of first order control system. Okay, so remember this. I will define what is the steady state error, and also we can see what is the transient response as well. That is steady state response and transient response. Steady state error we will be discussing in further videos. As of now, we need to see what is steady state response and all. Okay, and just for briefly, I'll give you how to calculate steady state error. So this is the time response of first order control system. Okay, now let's see the graph of this equation. So this is the graphical representation of this equation c of t. Okay, as you can see, this is the u of t function. The value is 1. Okay, so u of t is applied to a control system which is of first order. Then the c of t is the output. This is the output. So we need to just substitute first value of t is equal to tau. At that time, what will happen? C of t will become 1 minus e raised to minus tau upon tau. This is equal to 1 minus e raised to minus 1. This is equal to 0.63. That is represented here. Okay. So I didn't drew it properly. It should have been little more here. Okay. I hope you got the point. Now, if t is equal to 4 tau, then what happens? The equation will be c of t is equal to 1 minus e raised to minus 4. Okay, then the value will be 0.98. So it is represented here. Now unit step is equal to 1. So at t is equal to 4 tau, the response will reach 0.98. It won't reach 1. So it will reach the maximum value, that is equal to 1, which is the value of input, only at t is equal to infinity. So once t is equal to infinity, at that time it will reach the value 1. Okay, at that time both input and output will be equal to same, which is equal to 1. So you can see how as the time grows, the output is growing. It suddenly won't reach the value of 1. It will take certain time, almost 4 tau. Okay, for t is equal to 4 tau, it reaches the 0.98 times the value of this one. Okay, so you can see the response is exponential time, and it only reaches the value of 1 at t is equal to infinity. So you can see there is certain error here. So that error is defined as e of t. which is equal to R of t minus C of t. Now R of t is input, which is U of t, and this is C of t. So at t is equal to 4 tau, the error is 0.02. Okay, so this is the steady state error. Okay, so the steady state error becomes 0 only at t is equal to infinity. So now we can define what is the transient response and what is steady state response. So up to here, the response which you got is transient response. So yesterday I was talking about the example of how much time the car takes to start it takes after you start the ignition. Okay, so initially it will make some noise, or it may take some time to reach the value here. That's when the car will start. Okay, so this is steady state response. So in this way, it is very important to study the transient response and steady state response. So let's take car as an example, as we were discussing in previous video. For a moment, imagine that a car engine is of first order control system, that is, it has transfer function C of S. So this is the engine here, and you start the ignition. So at t is equal to 0, you start the ignition. It means the car engine takes almost t is equal to 4 tau to run properly. So we expect engine to run in a particular fashion. So it runs only at t is equal to 4 tau. So only after this amount of time the engine will run properly. Okay, so we'll get to know the time response of this car. So if you have another transfer function, if you design the car in different way, it may have a better response. Okay, however, if you imagine the car engine uses first order control system, that means it takes minimum 4 tau. So that's how the transient response helps us to understand the control system performance with respect to time. Okay, practically you'll get to know how much time the engine takes to run properly. So coming to the steady state response, it means, say you started the car and you started driving it. After 10 minutes, it reaches the steady state. Okay, it means the engine is running properly as expected. So with the help of this time response, we can analyze the transfer function of control system, or here in this case engine is a system. We can analyze the pros and cons of the control system, and also we can improve that. So that's how the time response helps us. So we studied with the help of input is equal to unit step function. So there are other types of input such as ramp, etc. So you can study the time response for such inputs as well. So remember that this is the time response of first order control system. There is also the second order and all. So we'll be seeing one by one. This series may take few videos. Hopefully, keep watching every video. It will make sense. And also, if you have any doubts, you can use the comment section. So this is all a series for mainly for GATE examination, and also for students who are studying in control systems in the 4th semester. Okay. So thanks for watching the video, guys. Please subscribe to our channel, and also tell your friends also about this channel. Thank you.